Okay, let's solve today's problem. Today's problem is 67, add binary. We've been given two binary numbers in their string kind format. We should return their summation also in binary string format. So the input are both non-empty and contains only characters 1 and 0. So we don't need to verify that these strings are actually, you know, if we remove the quotation, they are valid binary numbers, basically what this line is saying. So the example here, we get 1, 1, and 1. So when we add these two together, 1 plus 1 is 1. We're going to carry 1, and we have 0 in that position. We have 1 plus 1. This 1 plus, we don't have any digits here, but we have 1 carry, so 1 plus 1, we get 1, 0 here. So it's 1, 0, 0. And the second example, we got 1, 0, 1, 0. Adding that to 1011, the result we get is 10101. So it's 1 digit longer than these two things. It's the same for this one here. So to code this up, the most straightforward way to do it is just to simulate how humans would do this binary number additions. So let's use the second example as an example to show that how human will actually solve this problem. Let's say that we wanted to add these two numbers together. So the way that we do binary number additions is similar to what we do with decimals. We add the digits in the same. We align the two numbers first, and we add the digits in the same location. But the overflow happens at 2, right? At this particular location, 0 and 1, when we add those two together, we get 1, and there is no overflow, no carry. When we add this two number, 1 and 1, the result is 2, but 2 exists, it's bigger than or equal to 2, so we have an overflow, we have a 0 in this position, and we have 1 more carry. Let's just code carry as another additional number there. We got a 1 here, and in the very last location we got a 1 and a 0 and the overflow 1 here. So the result is 10101. So that's how we do the binary adding two binary numbers together as a human. So the most straightforward to code this problem up is to simulate this process. We align these two numbers, we iterate them from the right hand side towards the left, and we use something to keep track of the carry, and use some kind of a collection to collect all these individual digits here, and in the end we try to piece all this stuff together as return that as a final result. So that's the pretty much the approach. The time and space complexity in terms of that, both of those are equal to in the order of the maximum length of these two input strings, because you can see here the number of additions that we need to do, operation we need to do, is upper bounded by the maximum length of the one of the input numbers, and the space is just to hold the result, which is also equal to the maximum length of this two number. Maybe add 1 as the additional carry there. That's the time and space complexity. So let's quickly code this question up. So we are looping these two things in their reversed order. For the character A and character B, in zipping these two things, we reverse this A, we reverse those two. Actually, we should use this, I think itertools has a zip longest. What this zipping does is to have an option to pad the shorter ones with whatever default value we can specify. So look, example here, 1, 1. when we add this two in the regular zip, we will be terminated at this location. Just after the only one calculation, because the shorter ones only have one element in it, a digit in it. But for the zip longest, we can pad these shorter ones with 0. This is just some convenient functionalities. You can always pre-pad by yourself. Just take the length of the two strings and pad the shorter ones with zeros. But this is just a little bit more convenient. And it reads just like English. For these two digits, we're zipping these two strings in the reversed order, and we pad whatever the smaller one with zeros to the left. Then we should do the calculation. The carry and the remainder. Div mod, say int, convert this string characters char into integer numbers so that we can do additions, plus the previous carry, and divide that by 2. We take the carry and remainder from this div mod. Then the remainder is going to go to our collection. In this case, I want something I can append to the left. So we use a deck. Deck is basically a double linked list. Doubly linked list. Doubly linked list, so we can insert from left or right. You can use list as well, just regular default, so something shipped directly out of the box. But when you append to the right, I imagine that in the end you have to do a reversal. So we add the reminder to the result. And finally, if the carry is non-zero, so even though we exhausted all the digits here, we don't have any addition of this happening, but we have one additional carry. We should also add that to the result. Let me copy this. And of course, carry starts with 0, so we don't have any sort of like a debt in the calculation. And in the end, we should just return the string builder concatenating everything together, join, but we have to cast every element from integers into strings. So that's we use this string function to convert every element in result into strings and just concatenating them all together. So this should be in our algorithm. Let's see, let's do some final checking if I have anything wrong. It looks all good to me, so let's try submit and see what happens. Okay, it works. Okay. So this is the one of the method of solving this problem. Just try to basically implement the way that human would do this binary number additions. We add numbers, bit by bit, and that's how to solve it. Let's talk about another approach. So another approach, I guess, is if you know it, you know it. If you don't know it, and there's no hint on that's what exactly the that's what the interviewer is wanted, then you're gonna be stuck in there. The other way of doing it is to using the bit manipulations. So what we can see here is that just take this example here as well. Just to do a binary number addition without using actual addition, we can do that with I think it's exclusive all and left shift. The rationale is that the exclusive all here, like a 0 and 1 here at the last position, the exclusive all is just going to be 1. So if we have 1 and 1, the exclusive all is 0. So basically exclusive all gives the remainder, and AND operation, if you have two 1s, that's the only case you will get a 1, or a remaining case you're gonna get a 0. This gives the unshifted carry, and if you do this, shift that to left once, you get the let's say the correct carry. And like the example here, if we treat this carry as something like 0 1 0 0 1 0 0 0, we essentially are adding things. We essentially are doing additions of this two number, then the result, the remainder result, have to do another addition with this carry number, and then we have to use the remainder result to do another additional addition with this carry number. So that's just you kind of need a loop to do this addition to get to the final result. The termination criterion is that you no longer have any carry number there. So basically you can treat this second number as a carry and the first thing as a remainder. So let's code this up. We first convert these two numbers into binary integers, and while we still have some kind of carry number, the second number, we treat that as carry. What we do is to the A is the remainder, that's the exclusive all, and the B is going to be the shifted version of the carry, the correct carry. So that's A and B, and we shift that to left of 1 by 1 position. And then in the end we should return what is that we should return? We should return the binary string representation of A. I think Python has it's 02 in front, 0b in front to indicate the string is binary, so we don't need that indicator, so we should just return this. Let's see if it works. Yeah, I think so. Yeah, it's actually faster, but somehow it's using more memory. But this number, I don't know. It might be just some kind of overhead or random initiations. I also noticed that the runtime number also varies a lot, differs by runs. Yeah, so don't take this thing too seriously. You should always analyzing the time and space complexity for this by yourself. Yeah, so on that regard, let's talk about, think about what kind of time complexity we need for this thing. So for this, I'm not sure if it's the maximum length of this too. For our straightforward implementation, it's the simulation method. It's very clear that it's equal to the maximum length of this. But for this one, it's actually hard to think about. Um, the time complexity. It appears to me that it should be longer because this while loop is um, it seems that it's taking more, but I don't just right out of my head know the number. So yeah, I'll look it up and try to think about and then maybe post the comments down there. Or if you know, you can leave a comment. That would be very helpful. So that's the question for today. Thank you very much.